Good morning, dear students. My name is Ferhan Mazher, and today is 23rd of November 2021. Right now, I am with the 11th Cambridge class, and the subject we are studying is Physics 50554. This is Cambridge O Levels Physics, and today we have set our hearts to solve an MCQ paper. We call it paper 1. It's a 40 marks paper. The time allowed is 1 hour. And today we have selected May-June 2007, paper 1. And this is basically zone 2 paper. At that time in 2007, there was no zones. So we call it zone 2. So let's start this paper. And this is MCQ paper. Hopefully you will enjoy this. Okay, so let me go to the paper. Okay. So May-June 2007, paper 1, multiple choice question. And this is University of the Cambridge International Examinations, General Certificate of Education, ordinary level. So 1 hour is allowed. Okay, so let's start this paper. The width of a wooden block is measured using Vernier calipers. What is the width of the block? So here you can see that this one, that's the main scale. And this one here, this is the vernier scale. So the first of all, I will check that the zero of the vernier has moved how much on the main scale. Zero of the vernier has moved how much on the main scale. So this is the zero of the vernier scale. And this is the main scale. So this is 5, 6, 7, 8, 9, 10. So probably this is 4, this is 3. So the zero has moved 3 point something. So it's on the right side of the 3. So it has moved 3 on the main scale. So 3 millimeters. So on your rough work, note down 3. Let me show you how I do this. So I will note down, for example, I will note down 3 point, and because this is millimeter, so this is millimeter. Then I will check that which line of the vernier scale is exactly coinciding with any line on the main scale. So this is not coinciding, this is not coinciding with any line, this is not coinciding with any line, this is not coinciding, this one is coinciding. So this reading is 5. So it will be 3.5 millimeter. So the reading is 3.5 millimeter. So it's A choice. So the choice is A, 3.5 millimeter. So let's check. Question number 1, A part. A is the choice. Yeah. He says, which of the following correctly lists one scalar and one vector quantity? So displacement is a vector quantity, so this cannot be the answer. Energy is a scalar quantity. Force is a vector quantity. So this is the option. B looks the right option, sir. C, force is a vector quantity. D, velocity is a vector quantity. So they are in the wrong column. So B is the right answer. Energy is a scalar quantity, whereas the force is a vector quantity. So B is the right answer. Question number 2, B is the right answer. Okay. Let's go back. A student drops a table tennis ball in air. What happens to the velocity and to the acceleration of the ball during the first few seconds after release? So when you drop a ball at the start, because the velocity of the ball is 0, so the air resistance acting on the ball is also 0. The downward force acting on the ball is the weight, and so the only force acting on the ball at that moment is its weight. At that time, the acceleration is equals to the acceleration of the free fall, and that is 10 meter per second square. So as the ball starts falling downward, its velocity increases. So when the velocity increases, the air resistance also increases. Air resistance is opposite to your motion, the body which is falling downward, and the air resistance will be opposite to that motion. So the resultant force, which will be weight minus air resistance, that will gradually decrease. So at the start, the resultant force is equal to the weight, and there is no air resistance. But as the body is falling down, its velocity is gradually increasing. And due to that, the air resistance acting on the body is also increasing. So the resultant force acting on the body is decreasing. As the resultant force decreases, the amount of acceleration also decreases. But its velocity continues to increase. But the increase becomes, the increase is coming at a lesser rate. So the rate of increase becomes smaller. So as the body is falling down, its velocity will be increasing, but its acceleration will be gradually decreasing because the resultant force acting on the body is gradually decreasing. The main reason is because the velocity speed, the body is speeding up, it's gaining speed, it's gaining velocity. So the air resistance is also increasing. So that's why the resultant force is decreasing. That's why the acceleration is decreasing. So the velocity should be increasing and the acceleration should be decreasing. So we think that C is the choice. So let's check. Yeah, our answer is right. Okay. The next part. A car is brought to rest in 5 seconds from a speed of 10 meters per second. What is the average deceleration of the car? You know, a car is brought to rest in 5 seconds. The time taken is 5 seconds. And from a speed of 10 meters per second, the initial velocity is 10 meters per second. The final velocity is 0 because the car is brought to rest. So the final velocity will be 0. Initial velocity is 10 meters per second. And this change took 5 seconds. So what's the deceleration? The formula. That formula is acceleration is equals to the final velocity minus initial velocity, the whole thing divided by time. So let me show you my work. I've done this numerical, so let me show you. Okay. So you can see that on your screen, that numerical question number 4 is showing up. Initial velocity is 10 meters per second. The final velocity will be 0 meters per second. The time taken is 5 seconds. The acceleration, the formula for the acceleration is V minus U divided by T. 0 minus 10 divided by 5. So it will be minus 2 meters per second. So hopefully you understand. So the value of the acceleration is minus 2 meters per second square. Here we should write square. Okay, I have not written it the square. And so here we should have written square. Okay, here this is power 2. Okay, so yes. Okay, so let's check. Okay, so the deceleration will be, because the word deceleration is used, so we don't have to put a negative sign because deceleration word means negative expression. So I think B is the choice. So let's check the answer. 4 is B. Okay, our answer is right. Okay, so now we have question number 5. The propeller on a boat pushes water backwards with a force of 2000 Newton. The boat moves through the water against a total resistive force of 1800 Newton. So this is the direction of the motion of the boat. The resistive force acting on the boat is 1800 Newton. The propellers are applying 2000 Newton force on the water. So what will happen? The water will apply 2000 Newton force on the propellers. According to Newton's third law, what is the forward force on the propeller due to the water? Because the propeller applied 2000 Newton force on the water will apply 2000 Newton force on the propeller. So it will be this. So B is the right choice. Question number 5. I think B is the right choice, sir. Yep, it's 5. B is the answer. A student does an experiment to estimate the density of an irregularly shaped stone. Which items of equipment are needed? So you see, we want to find out the density of an irregularly shaped stone. So basically, to find out the density, you need two things. One is we need to find out the mass. For that, I will require a balance, some kind of balance, electronic balance, pan balance, top pan balance. So for the mass, I need balance. And then I need to measure the volume of this irregularly shaped stone. For that purpose, we will use the measuring cylinder filled with water. So which items of equipment are needed? A balance and a measuring cylinder containing water. I think this is the right answer. A balance and a ruler? No. A ruler and a measuring cylinder containing water? No. Only a measuring cylinder containing water? No. For mass, I need a balance, and for the volume, I need measuring cylinder. So A is the choice. Question number 6, A is the right choice, sir. Okay, so next question. Here we go. Forces are applied to a uniform beam pivoted at its center. Which beam is balanced? Okay, so here, if you look at these two forces here, the force which is on the right side is acting downward, so it's trying to produce a clockwise turning effect. This force here on the left side is acting upward, so this is also producing clockwise turning effect, so they cannot balance each other. Because both of them, they are clockwise, so they will not balance each other. These two forces, this force is acting downward, and it is trying to produce a clockwise turning effect about this pivot. This force here is on the left side, is acting downward, and is trying to produce anti-clockwise turning effect. So yeah, they might balance. So just multiply this force with this moment arm and this force with this moment arm. If their answers are same, then this thing can be balanced. So when you multiply 10 with the 0.4, that gives you 4 Newton meter. And when you multiply 10 with 0.2, this gives you 2 Newton meters. So the clockwise moment and the anti-clockwise moment, they are not equal to each other. So the B will not be balanced. Okay, now look at the C. This force is trying to produce a clockwise turning effect about this pivot. This force, which is acting downward, this is trying to produce also clockwise turning effect. So they cannot balance each other. In the D choice, here this force is trying to produce clockwise turning effect. This force on the left side is trying to produce clockwise turning effect, anti-clockwise turning effect. They might balance each other. So multiply this force with this moment arm. So 10 multiply 0.2, that gives you 5 multiply 0.4, that gives you 2 Newton meter. So the anti-clockwise is 2 Newton meter, and the clockwise moment is also 2 Newton meters. So they will balance each other. So I think D is the right choice. I think D is the right choice. Let me show you. I think I have done this on a paper also. So here I have shown only you can see that here in my solution, I have only shown you the B option and the D option, because in these two options, one force was clockwise, the other force was trying to produce an anti-clockwise, and then there are chances that they will balance each other. So in the B part, you can see in the B option, the moments, they are not equal to each other. So, but in the D option, you can see the clockwise moment and the anti-clockwise moment about the pivot, they are equal to each other. So they will balance out each other. So we think that D is the right choice. So D is the right choice, sir. Let's check the answer. We think that D is the right choice. We think that D is, let me show you the whole question first. So we think that D is the right choice. Question number 7, D is the right choice. Okay, so we are moving to the next question, and that question is question number 8, and it says a steel spring is stretched by a load. The load is increased at first, the extension is proportional to the load. The spring reaches its limit of proportionality at L. What is the correct graph of the extension against the load for the spring? You see, as you will increase the load, the extension will increase, but after you have crossed the load and the limit of proportionality, the graph will all of a sudden starts curving upward. So to me, this looks as it looks that the D looks the best option to me. So let's check. You see here extension load, as you're increasing the load, the extension is becoming smaller and smaller. Here, I think before the limit of proportionality, the extension and load, they should be directly proportional to each other. So the graph should have a positive and a constant gradient before the limit of proportionality. And after you have crossed the limit of proportionality, the graph should bend upward. So I think D is the best option, sir. Let's check. Question number D is the right option. This was question number 8. Question number 8, I think D is the right option. Yes, D is the right option, sir. The diagram shows a battery-operated motor lifting a block of wood at constant speed. What is the overall energy change taking place? So we are using battery, so that battery has a chemical. That battery has chemical potential energy, and that will be converted into electric, and then that electric will be converted into mechanical, and finally you will have because the wooden block will go upward, so it will have the gravitational potential energy. Because the wooden block is moving with a constant speed in upward direction, that's why we don't say that its kinetic energy is increasing, because its speed is constant. So we think that at the start there was chemical potential energy, and at the end, at the very end, the gravitational potential energy increases of the wooden block. So I think A looks the best option to me. Yeah, A, to my point of view, A is the best option. Let's check. Question number 9, A is the right answer, sir. Okay, now 4 students exercise in a gym. Which student does the most work? So here we have power developed and the exercise time. So here you have the power and you have the time. So the work done is equals to, the power is equal to work done divided by time. So work done is power multiplied time. So work done is equals to power multiplied time. So in all the 4 options, you have the power, you have the time given, you multiply them. So then we can see that who in which option the most work is done. So then we will be able to tell that in which option the most work is done. Okay. So here we go. So in the first option, 50 multiplied 250, that will give you 12,500 joules. In the second option, 100 into 150, so that will be 15,000 joules. And then we have work done is equals to 200 multiplied 200, so that will be 40,000 joules. And in the last option, the work done will be 250 into 30, and that will be 7,500 joules. So the most work done is 40,000 joules, and that is done in the C option. The most work done is 40,000 joules, and that is done in the C option. So option will be C. So the most work done is in the C option, and that will be the choice. So question number 10, C looks the best option to me. Okay, the C is the right option. Which formula gives the efficiency of an energy conversion? Efficiency is basically useful energy output divided by total energy in. The formula for the efficiency is useful energy output divided by total energy. So that is efficiency. So I think C is the right option. The exact definition is in the C. Question number 11. C is the right option, sir. A gas is trapped inside a cylinder by a movable piston. The length of the gas column is 50 centimeter and the pressure inside the cylinder is P. So when this length is 50, the pressure here is P. And you know the cross-sectional area, whether the piston is here or the piston is here or the piston is here, the cross-sectional area of this cylinder will remain same. And you know the volume is equals to cross-sectional area multiplied length. So the piston is pushed in a distance of 30 centimeters, so that the length of the gas column is now 20 centimeters. The temperature of the gas does not change. What is the new pressure of the gas? So the piston moved in 30 centimeters. So now when it has moved 30 centimeters to the right, so the gas will have the length here. The piston will come here. So the length of this gas will be only 20 centimeters left, because you moved in 30 centimeters. The total length was 50. So if you have moved 30 centimeters, so the gas will have how much length? It will have only 20 centimeters. And its cross-sectional area will be same as the cross-sectional area is here right now. So what is the new pressure of the gas? And you know the formula for the pressure is P1 V1 equals to P1 V1 is equals to P2 V2. So the volume 1 will be the cross-sectional area multiply the length of the air column, that's 50. P2 will be the question, and the area is still the same, but the length is 20 centimeters of the air. So if you want to find out the value for the P2, so it will be A and A will cancel from both the sides. Cross-sectional area is same. So 50P is equal to 20P P2. So the P2 will, this 20 will go on the other side, divide. So you will have 50 divided by 20. And that will be P. So the P2 will be 5 divided by 2P. So that is 2.5P. So that's question number 12. The pressure 2 will be 2.5P Pascal. So I think D is the right option, sir. 2.5P. Question number 12, D is the option. Question number 12, D is the right option, sir. A liquid is heated. Which statement is incorrect? The molecules expand, the molecules never expand. Remember that. The molecules gain energy. Yes, they gain energy. The molecules move further apart. A liquid is heated. No, the molecules will not move further apart. The molecules move faster. Yes, because you are heating. So the temperature of the liquid will be increasing. So that's why we can say the molecules move faster. So I think question number 13, D looks to me the best option. Let's see. Question number 13. Oh, question number 13, he's saying A option. Let's again check again. A liquid is heated. Which statement is, which statement is incorrect? So I gave you the correct statement. See, this is a very tricky thing. They are asking which statement is incorrect. A liquid is heated. Which statement is incorrect? The molecules expand. Yes, this is incorrect. So I think A is the right choice. Question number 13, A is the right choice. Yes. What describes the molecular structure of a liquid? Distance between the molecules. We are talking about a liquid. So the distance between the molecules will be close together. Motion of the molecules will be random. And they will be close together. They will be random. Strength of the forces between the molecules will be fairly strong. Fairly strong. Okay. B looks to me the right answer. Let's see. B is the right answer, sir. That's question number 14. A thermocouple thermometer uses a voltmeter to measure the EMF generated between two junctions. The junctions are at temperatures T1 and T2. To calibrate the thermometer, fixed points are needed. What are the values of the T1 and the T2 when the thermometer is calibrated at the steam point? You know, at the steam point here in the cold junction, we will have the melting ice, and here you will have the steam. So one junction will be in the boiling water where the steam is produced, and the other junction will be in the ice. So the T1 should be 0 and the T2 should be 100. What are the values of T1 and T2 when a thermometer is calibrated at the steam point? T1 is at 0 degree centigrade and the T2 is at so we are looking for the steam point. So the T2 must be at 100 degrees centigrade. So I think B is the right option, sir. Let's check. Question number 15, B is the right option. What is the definition of the heat capacity? The heat capacity is the amount of energy needed to raise the temperature of a body through 1 degree centigrade. The quantity of heat required to raise the temperature of an object through 1 degree centigrade, that is known as the heat capacity. So A option is the quantity of heat required to raise the temperature of an object through 1 degree centigrade. The quantity of heat required to raise the temperature of 1 kg of a substance to 1 degree centigrade. Yeah, that's the definition. The quantity of the heat required, okay. The quantity of the heat required to change 1 kg of a substance from solid to liquid without a change in the temperature. So, which is the definition of the heat capacity? Is the quantity of heat required to raise the temperature of an object to 1 degree centigrade. So I think the quantity of heat required to raise the temperature of 1 kg of substance to 1 degree centigrade. So both looks good to me. Let's check. Question number 16, A is the choice. A quantity of heat required to raise the temperature of an object to 1 degree centigrade. Yes, A is the best option. Question number 17, fillings in the teeth should be made from a material which expands and contracts as your teeth is expanding and contracting. So expands more than the tooth when heated, no. Expands by the same amount as the tooth becomes heated, yes. Expands less than the tooth when heated, expands less than the tooth when heated, no. Does not expand when heated. So the teeth the fillings in the teeth should be made from a material which expands by the same amount as the tooth when heated. So I think B is the choice. 17 is B option. A double glazed window has two sheets of glass separated by a layer of air. Thermal energy is conducted and convected through the layer of air. The amount of conduction and convection varies with the thickness of the layer of air, as shown in the graph 2.5. So here you can see thermal energy heat transfer through a double glazed window, and by convection and conduction, this is that line. So the total energy transfer by conduction and convection. So this is the total energy transfer by conduction and convection. So at this point, you have downward curve, then upward curve. So this is the main point here. Which thickness of air produces the smallest energy transfer and why? So there are many options. If this is in, you see, 0.5 centimeter, because there's a little convection. You see, if you look at the graph here, at this value, one I think centimeter, this graph which shows the combined effect, that has the minimum value. So which thickness of the air produces the smallest energy transfer? So 1 centimeter, because the total thermal energy transfer is least. So I think question number 18B looks the right option, sir. Check. Let's check. B is the right option. The diagram shows a water wave in a ripple tank. The wave has a speed of 12 centimeter per second at R. Okay. So now here we have the ripple tank. Here the water is deep, and here the water is shallow. So if I know the wavelength, you know, V is equals to F lambda, and F is equals to V by lambda. V is equals to F lambda. So F will be equals to V divided by lambda. So in the first portion, I know the speed, I know the wavelength. So I can find out the frequency. The wave crosses the boundary PQ, where the distance between the crust changes from 3 centimeter to 1.5 centimeter. What is the speed of the wave at the S? Okay, so I have done this on a paper. Let me show you my work. Question number 12. P1 V1 equals to P2 V2. The P will be cross-sectional area multiplied 50 equals to P2. That will be cross-sectional area multiplied 20. So area and area will be cancelled. So now you are left with 50 P equals to 20 P2. So that 20 can go to the other side. It will divide. So P2 will be equals to 50 divided by 20 P. So that will be like 5 by 2 P. 2.5 P. 2.5 p. 2.5 p. So let's check. Let me go back. Sorry. Sorry, I think question number 12. Yeah, question number 12 we have done. Okay. By mistake, I was reading the. Okay. So question number 19. I'm sorry. By mistake, I was looking at this wrong slide. Question number 19 is here. So in the deep water, the speed is 12 centimeter. The wavelength is 3 centimeter. The frequency is question. So deep water speed is 12 centimeter per second, and lambda is 3 centimeter. Frequency is question. So you will have V is equals to F lambda. So F will be equals to V by lambda. So F will be equals to 12 divided by 3, and that will be 4 hertz. So the frequency here will be 4 hertz. So in the shallow water, the wavelength you can see from the figure is 1.5 centimeter. The frequency will remain the same. When the water waves move from the deep water into the shallow water, the frequency do not change. So whatever this frequency here, same will be the frequency here. So now you will have V equals to question mark. So V is equal to F lambda. F is 4 hertz. The wavelength is 1.5 centimeter. So the V here will be 6 centimeter per second. 6 centimeter per second. So let's check. Let's check. 6 centimeter per second. 6 centimeter per second. So I think B is the right option, sir. Question number 19, B is the right option. Question number 19, B is the right option. Yes, B is the right option, sir. Okay. The diagram shows a child using a periscope to look at an object on the other side of a wall. Which diagram shows a correctly drawn ray of light from the object? So the light should come from the object. Okay, the first thing is this. So the light should come from the object. Okay, from the object, and then the light should go into the human eye, the observer's eye. So the light should come from the object. Okay. This looks good. This is wrong because the light is coming from the eye. That's wrong. This looks perfect. This looks perfect. Okay. And this is wrong because the light is coming from the eye. So that's wrong. So B and D, they are directly wrong. You can straightforward say they're wrong. Now, if you look at the A part, if I will draw a normal here, if you draw a normal here, you will observe that the angle of incidence and angle of reflection, they are not equal. If you draw a normal here with this surface, you will observe that the angle of incidence and angle of reflection, they are equal to each other. That's why the C is the answer. That is why the C is the right answer. Okay. C looks the right answer because when you draw a normal here, check the angle of incidence and angle of reflection, they will be equal to each other. So C looks the best option, sir. Question number 20, C looks the best option. So let's check. Question number 20, C is the right option, sir. what happens to light as it passes from glass into air? When the light will enter from glass into air, the speed of the light in the glass is less and the speed of the light in the air will be higher. So the light will bend away from the normal. Its frequency will not change. The frequency of the light will not change. Its speed will increase and its wavelength will also increase. Its frequency decreases because its speed decreases. No, frequency remains unchanged. Its B option is its frequency increases because its speed increases. That is also wrong. Frequency do not change. C part, its wavelength decreases because its speed decreases. You know, when the light will enter from glass into air, its speed will increase. So the wavelength will also increase. Whatever happens with the speed, same thing happens with the wavelength. So its wavelength increases because its speed increases. So I think D is the right option, sir. Question number 21, I think D is the right option. Yeah. Question number 21, I think D is the right option, sir. Which type of wave is used to send telephone signals to and fro from a satellite? For this purpose, remember, we use microwaves. It's a fact and very easy fact. Remember this. For satellite communication, we use microwaves. Question number 22, C is the right option. 2 is C, 22 is C. Yeah, our answer is right. So here we have a building. A girl standing 150 meters in front of a tall building fires a shot using a starting pistol. A boy standing 350 meters from the girl hears two bangs 1 second apart. From this information, what is the speed of the sound in the air? Okay, so you see, when this girl will fire a pistol, one sound will move directly from this girl to this boy. So that sound will only cover 350 meters and the boy will hear the first bang. Another sound will go towards this building. It will cover 150, collide with the building, reflect from the building, again cover 150, and then it will cover 350 meters and reach the boy. So this second wave, sound wave, has this sound wave which went to the building, got reflected and came to the boy. It has covered 150, 150, and 350. So totally this is 360 meters. So the sound which went directly to the boy, it covered 350 meters. The sound which went to the building, reflected, came back to the boy, that covered 650 meters. So the difference of distance traveled by both the sound waves is like 300 meters. And you know, he told us that the second bang came after 1 second. So this boy heard that after the first bang, he heard the second bang after 1 second. So it means that the second wave took 1 second to cover that extra 300 meters. So it means that speed of that sound wave is 300 meters per second. So I think A is the choice, question number 23. So let's check. Question number 23, A is the right option, sir. I can show you my work also. So here we go, question number 19, then we have question number 23. Okay, so let me show you my work. So the sound one, which went directly from the pistol to the boy, that sound traveled only 350 meters. The second sound, it covered a distance of 150 meters. It went to the building, and then it covered 150 meters from building to the girl, and from girl, it covered 350 meters to reach the boy. So this second sound wave has traveled 650 meters. So the difference of the distance between them will be 650 minus 350, that will be 300 meters. The time lapse between both the bangs the boy heard is 1 second. So it means that the sound took 1 second to cover 300 meters. So the speed of the sound is distance traveled divided by time. So that's 300 meters divided by 1 second, and that will be 300 meters per second. So question number 23, 300 meters per second. So A is the choice. I think we have checked the answer, and I hope you can understand this question. Question number 24. The diagram shows a brass rod and an iron rod beside each other at the bottom of a rectangular coil. What happens when a DC current passes through the coil? You know, the iron, that's a magnetic, that iron is a magnetic material. So when the current will flow through this rectangular coil, it will be magnetized, it will become an electromagnet, and the iron rod inside that rectangular coil will also become magnetized. But that brass, which is a non-magnetic material, this magnetic field will have no effect on the brass rod. So the question is, what happens when the DC current passes through the coil? Only the brass rod is magnetized. That's wrong. Only the iron rod is magnetized. Yes, that's right. The two rods attract each other. That's wrong. The two rods repel each other. That is also wrong. So I think that the C, only the iron rod is magnetized. Yes. B looks the best option. Only the brass rod is magnetized. That's wrong. Only the iron rod is magnetized. That is right. The two rods attract each other. That is wrong. Because the brass, it will not be magnetized. The two rods repel each other. That is also wrong. Only the iron rod is magnetized. That's the right answer, I think. Question number 24B looks the right option to me. Question number 24B is the right option. Question number 24, I think B is the right option. Yes, sir. Okay. Four metal rods are placed in turn inside a coil of copper wire. So here the coil is of the copper, and the inner core, the metal rod, we change it. Okay. Each rod is used to pick up as many paper clips as possible. The current is then switched off. The table gives the results of the experiments. So which rod is the most suitable core for a coil in a circuit breaker? The one which picks up maximum number of clips when the current is flowing through that coil, and it immediately loses all its magnetism once the current is switched off. So which rod is the most suitable core for a coil in a circuit breaker? It should pick the maximum number of paper clips, and the number of paper clips should be 0 when the current has been stopped. So I think 35C looks the best option, sir. C looks the best option. Question number 25, I think C is the right answer, sir. Question number 25, C is the right option, sir. Two uncharged metal spheres not touching one another are suspended by means of a cotton thread. A positively charged rod is brought near. Which diagram shows what happens to the sphere? So because this is positively charged rod, so on this positive charges will, because this is positive, so from here the electrons will be, because this is positive, the electrons will be attracted to this side. So this side will become negative and this side will become positive. And obviously this will be attracted. Okay. So, and then due to the presence of the charge on this sphere will also be affected. So I think due to the positive charge here, this side will become negative. So to me, it looks A is the best option. I don't know. Let's check. We have other options also. We have other options. So I think A looks the best option, sir. A looks the best option to me. These are not right options. It should not have banded this way. So that's why it's wrong. So question number 26. A is the right option, sir. Which factors will both increase the resistance of a wire in a circuit? Size of the wire, the length of the wire should become longer, the resistance will become larger. Temperature of the wire, the temperature should become higher. So the wire will have greater increase, there will be increase in the resistance. So the size of the wire should be longer and the temperature of the wire should be higher. So the wire longer, temperature lower, that is wrong because the temperature should go higher. The size of the wire shorter and the temperature lower, no. The size of the wire thick and the temperature higher, no. The size of the wire cannot be thicker because we want a lower resistance. No. Will increase the resistance. We want a higher resistance, sorry, I said lower resistance. So the thin wire with the higher temperature, yes, thin wire and higher resistance, higher temperature. So I think B is the best option, sir. Question number 27. D is the right option, sir. Question number 27. D is the right option, sir. Which graph best represents how current I varies with the voltage B in a component in which the resistance increases as the current increases? So this graph, its slope is I by V. The gradient of this graph or the slope of this graph is I by V. So the gradient is actually the reciprocal of the resistance. So the slope is equal to the reciprocal of the resistance. So whatever, if you want the resistance to increase, that the slope should decrease. The slope should decrease. I think the B is the right option. Because here the resistance is equals to, I know, the resistance is equals to the reciprocal of the slope. So if the slope will decrease, the resistance will increase. So I think B is the best option. Question number 28. B is the right option, sir. At which point in the circuit is the current smallest? So the current, whatever the current came out of the battery, the whole current will pass through this resistor. Here the current will be split in two parts, between two parts. So you see, because in this part, the resistance is higher as compared to the resistance in this part. So very small amount of current will flow from this part because here the resistance is higher. So the smallest current will be at the point T. Then here again, the current from this branch will join, and the current which came out of the battery, the same current will go back through this wire. So the smallest current will be in this 3 ohm resistor. 3 ohm resistor. So that's D choice. Question number 29, it will be D choice, yeah. So he says the diagram shows a circuit. The ammeter has negligible resistance. what is the resistance of the resistance R? So the voltage of the battery, the EMF is 3 volt. The current coming from the battery is 0.5 ampere. The total resistance in this circuit, because they are connected in series, will be R plus 1 ohm. So the EMF is equals to, I divided by the total resistance. From there, I can find out the value of the R. Let me show you my solution. So the V is equals to IR. So EMF is equals to I multiply the total resistance, and that will be R1 plus R2. EMF is 3 volt, and the I coming from the battery is 0.5 ampere. And the R1 is R, and the R2 is 1. So R plus 1. So you will have 3 equals to 0.5 into bracket R plus 1 bracket close. So this 0.5 will go on the other side. It will divide. So you will have 3 divided by 0.5, and that will be 6 equals to R plus 1. So R will be equals to 6 minus 1, and that will be 5 ohm. So the value of the R in that case will be 5 ohm. 5 ohm. Let me show. 5 ohm. So question number 30, 5 ohm. C choice. Yeah. The diagram shows the circuit of a hair dryer. The fan has a power rating of 0.1 kilowatt, and the heater each have a rating of 0.4 kilowatt. The cost of electricity is 8 cents per kilowatt hour. What is the cost running the dryer for 2 hours with the switches P and Q closed and the switch R open? So when the switch P is closed, this fan will be working. When the switch Q is closed, this heater will be working, and R is open, so this heater is not working. So one heater and a fan, they both are open. And so they have been working for 2 hours. So the fan, I know its power. I know the power of the fan. I will multiply it with the time, that's 2 hours. And then I will multiply it with the price. The heater is also working. So the power of the heater is 0.4 kilowatt, and it operated for 2 hours. And the price is 8 cents per kilowatt hour. So power multiply time multiply price. So that will give you the cost of the heater. So you add both the cost, that will be the total cost. So let me show you. The energy is equal to power multiplied time. Energy used by the fan plus the energy used by the heater. Energy is power multiplied time, so it will be 0.1 kilowatt multiplied 2. So it will be 0.2 kilowatt and kilowatt hour. And the energy used by the heater, 0.4 kilowatt multiplied 2 hours. So you will have 0.8 kilowatt hour. So 0.2 plus 0.8, and that will be 1 kilowatt hour. You know, the cost of energy is equal to energy multiply the price of 1 kilowatt hour. So 1 kilowatt hour multiply 8 cents per kilowatt hour. So 8 cents. The bill will be 8 cents. The bill will be 8 cents. The bill will be 8 cents. So let's check. The bill will be 8 cents. So I think D is the right option, sir. Question number 31. I think D is the right option. Question number 31. D is the right option, sir. Okay. Which circuit shows the correct positions for the fuse and the switch in the lighting circuit of a house? You know, the fuse and the switch, they must be connected in the live wire before the lamp comes in the live wire. The switch and the fuse, they must be connected in the live wire before the lamp is connected to the live. So I think C is the best option, sir. The fuse and the switch are in the live before the lamp is in the wire. So I think C is the best option, sir. Question number 32. Question number 32, C is the right option. Here we go. The diagrams shows the force F between two wires carrying currents out of the page. The magnetic field close to the wire are also shown. Which diagram is correct? You know, both the wires, the current is in the same direction. The current is coming out of the page. So if the current is coming out of the page in the option A, the current has the same direction, so they should attract each other. So A is wrong and C is wrong because here we should have attraction. We know that. This is law. If you have two parallel conductors, direction of the current is same. So they will attract each other. So either it's B or it is D, attraction. Now I can use the right-hand grip rule for the straight conductor to find out the direction of the magnetic field. You see the current is coming towards me, it's coming out of the page. The curls of my finger, the right hand, the curls of my finger, my thumb is in the direction of the current that is coming out of the page. The curls of my finger, they are anti-clockwise. So the direction of the magnetic field should be anti-clockwise. So on this basis, I can say that B is the right option, sir. Because here the current, the magnetic field shown is in the anti-clockwise manner. So B is the best option. They will be attracting and the magnetic field around them will be anti-clockwise. So I think B is the right option. So let's check. Question number 33, B is the right option. In a DC motor, the coil is wound on a soft iron cylinder. Why is soft iron used? Because it will concentrate all the magnetic coil for field lines inside it. To increase the strength of the magnetic field, that is wrong, 100%. So that is right, sorry. To increase the strength of a magnetic field, that is right, actually. To increase the weight of the coil, that's wrong. To insulate the coil from the magnet, that's wrong. To prevent the coil from spinning too quickly, that's wrong. So A is the best option, sir. Question number 34, I think A is the right option. So let's check question number 34. A is the right option, sir. The diagram shows how a magnet and a coil may be used to induce an electric current. How could the ammeter reading be increased? So when you will move this magnet, this ammeter will show the induced current. If you want to increase the current induced, the one easy method is move this magnet faster or move this coil faster. Another way is to put a core in this coil. So the first option is move the coil more slowly. That is wrong. Put a resistor in series with the ammeter. That's wrong. Turn the magnet around, then move the coil. No, use a coil with more turns. Yes. If you will use a coil with more turns, that will produce the reading on the ammeter will increase. So D looks the best option. 35. D is the right option, sir. Question number 35, D is the right option. A simple DC generator produces an alternating EMF as shown. So the EMF, its time period is 1 second and its amplitude or the voltage is 1 on both sides. So its EMF is 1 volt and the time period is 1 second. The speed of the generator is doubled. Which graph best represents the new output? So when you will increase the speed of the generator, when you will double the speed of the generator, you see the time period will become half. And the amplitude of this should become double. So the time period should become half and the amplitude should double. Before the time period was 1 second, the wave, one complete wave is in 1 second. So the time in 1 second now there should be 2 waves and the amplitude should become 2. So I think D is the best option, sir. To me, it looks that the D is the right option, sir. You see, when you double the speed of the generator, the time period will become half. If there was 1 wave in 1 second, now there will be 2 waves in 1 second, and the amplitude will become double. It was 1 volt before, and now it should be 2 volts. And in 1 second, there should be 2 waves. So that's why D is the right option, sir. Question number 36, D is the right option. We can confirm this. Question number 36, D is the right option. Question number 36, sir, I think D is the right option. Yes. Question number 36, D is the right option. A waveform is displayed on a cathode ray oscilloscope. The length of the 3 cycles of the waveform is 6 centimeter. The vertical gain and the time-based settings are shown on the diagram. What is the time taken for 1 cycle of the waveform? So let me increase the size. You can see this. So here we have 1 wave, 2 wave, 3 waves. So 3 waves took 6 centimeters. So it means 1 wave horizontally will take 2 centimeter. And you know, this vertical gain, that means the scale on the y-axis. So this is a graph, and what is the scale on the y-axis? This time-based actually tell you the scale which is used on the x-axis, on the horizontal axis. So on horizontally, there are 2 squares, and this is set on 2 milliseconds. So it means that the time period is 2 squares multiplied 2 milliseconds, because there are 2 squares horizontally, and each square represents 2 milliseconds. I know this from the time-based knob. So once you know this, we can find out. He says, what is the time taken for 1 cycle of the wave to form? So to complete one wave, it took 2 squares horizontally, and each square represents 2 milliseconds. So 2 multiplied 2, that will be 4 milliseconds. So I think C is the right option, sir. Let me show you the whole question. So I think C is the right option for question number 37. So let's check. Question number 37, C is the right option, sir. Which statement is true for all 3 types of radioactive emissions: alpha particles, beta particles, and gamma rays? They are completely absorbed by a thin aluminum sheet. No, the gamma cannot be stopped by the aluminum sheet. They are deflected by electric field. No, the gamma is not deflected by the electric field. They emit light. They ionize gases. Yes. They all of them, they ionize gases. Their ionizing power is different, but they ionize gases. I think D is the best option, sir. 38, I think D is the right option. So let's check. Question number 38, D is the best option, sir. Here we have the diagram shows one type of radiation passing between the poles of a strong magnet and being detected. Which type of radiation is being detected? Here you see, I can apply the left-hand rule. If you have your left hand with you, okay, stretch your fingers. I'm going to apply the left hand rule. These three fingers, thumb, middle finger, sorry, the index finger and the middle finger. And you know, thumb represents the force, and this index finger represents the magnetic field, and this middle finger represents the charged particles. So the charged particles are coming towards me. The magnetic field is going. The magnetic field is going from north to south, and my thumb is pointing downward. So these, if they are positively charged, they would have bended downward, but they have bended upward. You can see the detector looks little higher as compared to the source. So the particles have deflected upward. But when I apply my left hand rule, my thumb points downward. So because they are acting opposite to what my thumb is predicting. So because this left hand rule is for the positive charges, it means these charges, these particles are negatively charged. So they must be beta particles, and beta particles only. So I think B is the best option. Question number 39, to me it looks B. Let's check. Question number 39, B is the right option, sir. Question number 40, a nuclide has a notation of 2348. And which line in the table describes a different isotope of this nuclide? So isotope will be that atom which will have the same proton number, but its nucleon number will be different. Same proton number, but the nucleon number can be different. So the same atomic number is 20, because this one has 23. So here it should have 23 proton numbers, and its nucleon number is 50. That will work. So I think A is the best option, sir. A. Question number 40, A is the best option. So let me check. So 40. So, my dear students, we have reached the end of this paper. That was question number 40. Today, I'm not feeling well. You can see that I'm coughing because the weather here has, in Pakistan, the weather has become cold, and due to the fog, we have a little bit cough. So that was the May-June 2007 paper 1 of the physics. We were studying the Cambridge O-levels of physics 5054. Today we have done May-June 2007 paper. Hopefully you have understood this paper. So if you find this video helpful, if you find that this video has helped you to improve your concepts, don't forget to subscribe to my YouTube channel and like this video. Also, share this video with your friends and with your senior students and with your junior students. Because if this video can help you, that this video can also help them. This will be a good stuff, a good deed for them, and it will be a great appreciation for my work as well. So thank you very much, everybody. Have a good day, and God bless you all.